Okay. Right. So good morning all students. Moving on to the module 2, we will deal with the algorithm so called as the QuickSort today's class. So as in a recap, I had dealt with the matrix multiplication of Starson's method. So we had seen the algorithm, the example with respect to 4 cross 4, and similarly we had seen its analysis, and we could also observe with the analysis that the Starson's matrix multiplication gave me n to the power how much, students? You remember? n to the power n to the power normal matrix multiplication was n to the power what?
3, ma'am.
And your Starsons gave how much? n to the power? Could remember? At least approximate, not the exact. Lesser than n cube, right?
Yes, ma'am. N to the power of 2.807.
Eight something, right? So we had got that particular uh, order of growth, or I can tell the number of multiplications made. And when I check cross with n equals to 2, you can observe that 2 cube is 8 multiplication, and 2 to the power 2 minus 2 to the power 2.80 something will give you 7. Okay. So we had seen that in the last class. So today's agenda, as I told you, I'm dealing with QuickSort, but as I have already dealt in your lab class, so I will move a bit faster for this. And the algorithm design here, the analysis, the implementation portion that which we had already dealt in the lab class. Okay. And followed with that, you have an assignment. If at all, if I cover the example portion here, because we started late. So let's see. Okay. So as I told you, QuickSort is one of the famous sorting algorithm which uses divide and conquer technology or the technique to sort a given set of numbers. Before I go to the QuickSort example, what we are looking at, let me make you clear that there are several variations of QuickSort. So if you put in the Google and see QuickSort, there are several ways of doing QuickSort. The reason because the QuickSort deals with the selection of pivot element. So you all know what is a pivot element, right? So pivot element is an element which helps you in what task? In task of partitioning, isn't it? Right? There are several ways to select the pivot element. As I said, what is a pivot element in our problem or in our algorithm? Which is a pivot element?
First element, ma'am.
Element. So you can select the last element, you can select some random element or mid element or fourth element, something like that. Okay. So you there are several variations. If you can see, all the quicksort algorithm, the different variations are named with their inventors. Okay, something like Luto quicksort and Hore quicksort, right? Based on their inventor, they are being named. So we are seeing one variation of quicksort, okay, based on the pivot element. As I told, it is one of divide and conquer approach, a sorting problem. And as I told in the last class also, unlike merge sort, the quicksort doesn't divide the input element based on their position, but it divides them based on their value. This second point, which I put forth for you, is very important because sometimes in exam, they will ask you write algorithm that divides according to the value, sorting algorithm that divides the input according to their value. So you should not get panic. Oh, which is this? We know only merge and quick. It's quick sort. Okay, quick sort divides based on the value, and merge sort divides on the position. That is your mid position. Are you understanding? So when I tell the quick sort divides them according to the value, I deal with something called as a partitioning. So not division, but I tell it as a partition. As you all know, partition is something like you take some element A of S. So I partition in such a way that all the elements towards the left of A of S is less than, and all the elements towards the right will be greater than or equal to, less than or equal to. And you can observe in the diagram that I have not specified any pivot element and other things. Some element of S. Okay, wherein all the elements towards the left, the indices ranging from 0 to s minus 1, and all the elements towards the right, the indices ranging from s plus 1 to n minus 1 are less than or equal to e of s and greater than or equal to e of s respectively. This is called as partitioning. And remember students, this E of S, when I deal with partitioning, will be placed in its final position as that of the sorted array, and the left and the right part may not be sorted, but compulsorily they will be less than or equal to or greater than or equal to E of S, right? So obviously, as I told you, E of S will be in its final position in the sorted array. And we continue sorting the two subarrays which are to the left as well as to the right. Again, independently. I'll take this one first and this is the second one independently by choosing the same method which I followed. That is selecting the pivot and other things, right? And remember that with a merge sort, you can observe that I divide the problem into sub-problems, and then after that I combine the solutions. You observe that, isn't it? But what about quick sort? Am I combining the solution anywhere, or I'm simply dividing and making my work there itself in the division stage? Students, any idea? Am I combining in quick sort?
No, ma'am.
No, there is no work required to combine the solutions. Rather, my work is getting happening in the division stage only. In the division stage only, the elements get placed in the original array itself appropriately, one after the other. Isn't it so? Right? So, coming on to the algorithm, as I've already told you people, this algorithm we have already seen for the array A, and I have used L and R. You can use low and high. Low and high can be used for indicating the left and the right indices. I have used L and R, no problem. And input output you can see. If L is less than R, as you all know, this condition holds good whenever the array is having more than how many elements? More than how many elements?
One element, ma'am.
More than one element. That means to say, I will divide the problem whenever the array is having more than one. If one, I will not do anything. I'll just return back. I'll go backtracking will happen with respect to recursive call. And you can just observe here, I'm calling one partitioning method, passing the array A, L to R, wherein this partition will do whatever I said, okay, and then returns the split position. S is my split position, and remember, S is the final position of the pivot element which is being selected in the partition. So the reason why I'm telling all this, because I've already covered in the lab session. Then what does this first recursive call do for me? What does this first recursive call do? The first one will solve which half?
First half, ma'am.
First half. And what does the first half have? What elements will it have?
Elements which are lesser than the
Less than the
pivot element.
pivot element. This will be solved recursively. Again, the same procedure will be applied. So we'll see with example how the same procedure will be applied. And the second recursive call will solve for me the second half again recursively, wherein the second half contains the elements greater than or equal to the pivot. And you can observe the indices. So since S is the split position, I will pass only L to S minus 1, and here I will pass S plus 1 to R. Isn't it so? So remember, I am not passing S. The element under S is not being passed because it's already placed in its final position. It is also one of your Viva question. Why you are not passing S? Why it is S minus 1 and S plus 1? You should be able to answer. Right. So when we talk about partitioning, we have to select the pivot element, some element based on which you should partition your array. So that name is given as pivot element. Very simple. So as I told you, there are number of ways: first element, last element, random element, then mid element, median element, average. Many things you can have any kind of selection of pivot. So we assume here the first element in the array to be your pivot element. So that is 40. Okay. If at all this is the array given to me. Okay. So as I told you, given any pivot element, I'll have to just partition the elements of the array such that I get two subarrays, wherein the left side is less than or equal to pivot and the right side is greater than or equal to pivot. And remember students, the subarrays will be dealing only in the original data array. So I don't have any temporary array, other things I don't have. So whatever manipulation or whatever updation I'll be doing, it will be in the original data array. Okay. So to deal with the example of the partition, so I've already dealt with this. So I'll just quickly move upon it. Okay. Can anybody tell me how do I do partitioning, students? What is the procedure for partitioning? What scan should I do?
Ma'am, left to right when I is less than j.
Yes. So only left to right?
No, ma'am, while I is less than j, we will scan from left.
No, it's only, I'm talking is there is only one scan or you have two scans?
Two,
Two
ma'am,
scans,
two.
ma'am.
Two, ma'am.
How many scans? Hope I am audible.
Two, ma'am.
Yes. So what are the scans? Left to right and left to right,
Right to left.
right to left. Okay. So we have two scans to be done, and you can also observe that when I do left to right scan, I compare the elements of the array with the pivot element such that I continue the left to right scan till I encounter what element?
Element greater than pivot
Than the
element.
pivot. Yes. And then I'll do again, if I encounter an element greater than or equal to pivot, I'll just stop. The reason because you all know that towards my left of pivot, I need only less than, but I don't want greater than, isn't it? So I stop that left to right. Then again, I continue my right to left scan similarly, and I stop my right to left scan when I encounter an element less than or greater than pivot.
Less than, ma'am.
Pivot. So I just stop there. And I will check the values of I and j, provided if I is still less than j, then swap these two elements which are greater than and less than, which are in the out of order. Isn't it so? Right? So just swap it and continue the scan until I is I is what? What is the condition?
Greater than J, ma'am.
Okay, until I becomes greater than or equal to j. Until or till I can tell. Till I is less than j. There is a difference when I use until and till. Till I is less than j, keep doing it. Or until I becomes greater than or equal to j. Right? So once I is crossed j, you can observe that j will be pointing to the actual position of the pivot. So you will have to swap the pivot with the jth element. And remember students, I and j are the indices. Many of you get confused. I is the element. No, I is the index. I and j are the indices. Very important. Most of the time they ask in the Viva, what is I and j? Many of them will tell it is pointing to element. No, it is pointing to the index. Okay. So I'll just run through this because I've already dealt with this. So repeat I plus plus. until E of I is greater than or equal to pivot, right? So since I'm using repeat until, so it is like do while. Okay, I had initialized I to first element, J to the sentinel value. Okay, so I keep doing this. So tell me, where does this I stop for me? I am starting with my left to right scan. Where does it stop? At which index? Which index does it stop?
3, ma'am.
You can observe. So it stops at 3 because 80 is greater than 40. Next, I'll do repeat j minus minus until e of j is less than or equal to pivot. So you can observe, where does j stop for me? At what index? At what index j stops?
7, ma'am.
7. You can observe here it stopped at 7 and this stopped at 80. That is the index 3 and 7. And you can observe that I is still less than j. I is 3 and 7. Just swap them and keep repeating the same process. Okay, after swapping, you can see it is swapped 30 and 40, right? And repeat this process if I is still less than j. Go to 1. You can observe that when I becomes greater than or equal to j, you will have to stop this. Okay, so again I repeat the same, and you can observe I stopped at the index 4, which is 60, and this will stop at the index 6. Sorry, index 6 with the element 7. Again, you can see I is still less than J4 and 6. Swap it out. Okay. So like this, when I keep doing it, at some point of time, you can find that, right, your I is now crossed J, isn't it? So I has crossed repeatedly, you will do swapping and all other things. So you can now observe that I has crossed J. I has become greater to J. So what will happen if I is greater to J now? What should I do if I is greater to J? What does J point to, students? J point
Position of the actual position of the
of the
pivot
pivot element. So I just now need to swap. Very important. The pivot is stored at the index 0. That is the first element. That is low. Okay, in general, when you write the algorithm, right? So if I is greater than or equal to j, swap E of low with E of j. So when I swap, you can observe now 7 is placed here and 40 is placed here. And this gives you a clarity. Now you can see all the elements towards the left are lesser, all the elements towards the right are greater. And you can observe, students, one thing, they may not be in order. Sometimes they might be in order. We cannot predict based on the input, but lesser than and greater than it will be. And your partition should return the value of j, that is 4. Why? Because 4 is now acting as what position, students, for me? It is now the what position? What position is that? 4 is acting as what position, students? 4 is what position, students? Can I know that? 4 is now the
position to partition the
partition
array.
or the split, isn't it? So split position or whatever you tell, that is represented by the value of j, and that should be returned. And if you don't return this, again you are in a problem. You cannot get the split position. Very important that. Right. And you can observe that the elements towards the left and the right are less than or greater than to the pivot, which is at the index 4 now. Right. And remember, the quicksort actually divides the problem into 3 subproblems. You can see that first half, second half is your pivot only, and the third half. 3 subproblems, actually speaking. Okay. Now, how do you solve this left and the right? As you all know, again apply the recursion. Again do the same thing for this. Again do the same thing for this. Again, what should you do? Take 7 as the pivot, okay, and place it in the appropriate position. Again, divide the subproblem. Like that, you'll have to repeat it again. Fine. Um, yes. So the algorithm for partition, I'm taking A, L to R. So pivot is A of L. Remember, students, do not use the numbers. If you use numbers, you will not get any compile time error, but you will end up with runtime error. The reason because we are calling all the functions recursively. So it should be generalized L, A of L. Then I is equal to L, then J is equal to R plus 1. Okay, or you could have used J equals to R depending on how you will write the statements, while or do while. So based on that you can do. If you are using while, you can write I is equal to L plus 1. Okay, this could be written as R. So depends, this initialization depends on what kind of statements you are using. Okay, so repeat, I am using repeat, uh, repeat I plus 1 until A of I is greater than or equal to pivot. Repeat until is a pseudocode convention for do while. Hope you remember it. Then repeat J minus 1 until what, students? Until what's the condition? Until what?
A of j is less than
Than
pivot.
or equal to pivot. Then if I is less than j, swap A of I with E of j. So I've just given the pseudocode here. Okay. And this will repeat until I becomes greater than
Greater
or
than
equal to j. Okay, then again exchange A of low with E of j. Remember, students, many of you people, when you do in the lab, you will write exchange pivot with E of j. What will happen if you write here pivot? What will happen, students? Will it exchange in the array? Exchange will happen. I will not have any compile time error. Is it correct if I write here pivot?
No, ma'am.
What will happen if you write here in pivot?
Ma'am, A of J value is stored in variable pivot, ma'am.
Yes, pivot is a variable pointing to the A of L element. Okay, many of them will write this pivot. Ma'am, you told no exchange A of J with pivot, so I wrote pivot. That is the answer, or that's what madam told me. Right in the exam, you will tell. But pivot is an uh, independent variable which holds the value copy of the array element, isn't it? So if you do that, it will exchange with the variable, not within the array. So you should write E of L. Okay. See, all this will you will experience when you type the program and see. Okay. And very important, what should you return? What should you return, students? What should you return? Should you return from the partition algorithm?
position of pivot element.
Yes. What is that? Pointed by which
Pivot. A of j.
index? No, no, index.
J, ma'am.
Return J, very important. You have to return J. And many a times while typing, okay, typo error, you will write an I. Return I, you will not get any compile time error, students. Definitely you will not get any compile time because you are returning I. I is an integer value, no problem. But then your answer will again go wrong, right? So this is very easy, but when you are typing, you tend to make mistakes. Instead of j minus 1, you might write j plus 1, right? Like that. So you should be very careful. Okay. And one more thing, you will put exchange, this exchange also inside the while. So that will make again wrong. So you should be very careful here. Okay. So moving on to the analysis. So I'll not take much time. I'll just move forward with this. The analysis, when we talk about, there are two kinds of complexities that we have to deal because the time varies when depending on the input type. Okay. So whenever the elements, keys means to say the elements are random or uniformly distributed. Okay, random, some input you will give, right? There are two input type of input wherein the algorithm slightly varies with the number of comparisons it makes. The basic operation is nothing but the comparison here. So there's nothing to deal with more there, right? So what is the best case running time? Or I can tell, when does this best case running time happen? So basically, this best case running time will happen, okay, whenever your array is divided into exactly two halves. That is, each of the size n by 2. That means to say, the pivot is occupying which position in the array? If you could guess, exactly two halves or almost two halves means the pivot will be occupying which position in the array? Which position? If I have to,
Mid, ma'am.
mid position, very good. So the pivot will be partitioning the array into two subarrays of size n by 2. Are you understanding? In two subarrays of size n by 2. Right? So in this case, you can see that the QuickSort algorithm, which is applied recursively to each of the subarray, which is of size n by 2. Almost I can tell, not exactly n by 2, almost, because we are not including the pivot element, isn't it? So almost, right? So in this case, what will happen to the recurrence relation? The recurrence relation can now be stated as T of n, that is the C best of n. Okay, C best of n equals to 2 times of C best of n by 2, because I have two halves to be solved. Each of size how much, ma? N by 2, right? 2 C best n by 2 plus n. So why this n I require? Plus n is required to do my partitioning process. I'll first partition. So n comparisons I will make. So I'm not going into the depth, not required. This much is required for as per your syllabus. We'll just look into it. 2 times of C best n by 2 plus n. What is this n? N is the number of comparisons made for partitioning the array into two halves for n greater than 1, and C best of 1 equals to 0. And you know that when there is 1, I don't do any comparison when the size is 1. Okay. And you all know that this is same as your merge sort. Do you all agree with me? Isn't this recurrence relation same as the merge sort? Students? Isn't this same as the merge sort? 2t of n by 2 plus n minus 1 it was. But anyways, it is a linear function. Isn't it the same as the merge sort? Students? Yes or no? Okay, what is A? What is A here? Master theorem, if I have to apply, what is A, ma?
2,
2.
ma'am.
2. What is B?
2.
What is D? D is what? F of n expressed in terms of n to the power. What is D?
1, ma'am.
1. What is the relationship between A and B to the power D?
Equal, ma'am.
Equals. So equals is there. You can see, I think the second case will be applied, isn't it? Yes, right? So I think it is the same as that of your uh, the merge sort, wherein the best case will be omega represented by omega and n log n to base 2. This is happening when the partitioning will always divide the problem into two equal halves. Why? Because your partitioning element can be placed anywhere in the array, but if it is exactly placed in the mid, so you will have the best case. Okay. Then talking about the worst case running time. Okay. So what is the worst case running time? Just observe this array which I have given, which is already in order. So my input array is already in the order. Now just tell me, what are the two halves? What are the halves towards the left of the pivot? If pivot is 2, what are the halves towards the right? Just observe and tell me. What will be the towards the left of the pivot?
Nothing, ma'am.
Nothing. It is 0. The first half is 0. 0 sized. What is the second half? Size of the second half. Size of the second half.
Wait.
Okay. How
Okay,
many
2
elements?
second.
How many elements are there here? 4, 8, 9 elements are there. Okay. What is the size of the second half? Size of the second half. The size. How many elements will be there in the second half, students?
Ma'am, n minus 1.
One. Or you can observe here that, oh my god, you can observe here that the since it is in the order ascending order, first element is only the least one, so there is nothing towards the left, it is 0. And you can observe here that this is having how many elements? I think it is 9 elements. This will have how many elements, students? 8 elements. That means n minus 1 in general. If there are n elements, my first half will be 0 and the second half will be n minus 1. Okay, you can observe if I do all this partitioning, the left half is nothing. Less than or equal to pivot is nothing. Whereas the second half, you can see you have all the elements placed except the pivot, isn't it? So now you can observe here, partitioning will now split the array into two subarrays. One subarray which is of size 0, the other subarray is of size n minus 1. Now can you just tell me what will happen if the input is in descending order, students? If the input is in descending order, what happens? Which half will be empty? Descending order. Descending means uh, the highest will be here in the first position. Suppose in the reversed way, highest is this, say 100, like this. What will happen if it is in the descending order? Which half will be empty?
Second half, ma'am.
The second half. That is towards the right, it will be empty. This will be empty, right? Whereas towards the left, it will be again having how many elements? N minus 1 elements. So you will have either of the case, ascending or descending, whatever it is, one array, subarray will be of size 0, the other subarray is of size n minus 1. And you can observe the time complexity will be now T of n equals to T of n minus 1 plus T of 0 plus n. So you can omit this C, not required. So n. Why did I write T of n minus 1 and T of 0, students? Why did I write this? What does T of 0 indicate? Okay. T of 0 indicates what? Students. Time taken to sort which array? T of 0 indicates time
Second
taken to
array.
sort.
Ma'am, the second half, the second array.
No, no, no. Whatever it is, whatever is the case, what does T of 0 indicate? Because we don't know whether the input is in ascending order or descending order. So what does T of 0 indicate for me? T of 0 indicates what? The time taken to sort the subarray which is of size
1, ma'am. Okay, 0.
0, which is of size 0, because either of the half will be empty. So we don't know which is empty, right? Because we cannot predict what is our input, isn't it? So, and what is T of n minus 1 indicating? The time taken to sort recursively the subarray which is of size
N minus 1.
1. Very simple. Okay, T n minus 1 plus T of 0 plus n. And we all know that T of 0 is, what is it? Time taken to sort 0 elements. How much? Is it 1, 2, 3 or something else?
0, ma'am.
0 only. And this will be, recurrent solution will be T of n minus 1 plus n. So you cannot apply master theorem here. So you should apply backward substitution method. So if you apply backward substitution method, we have already dealt with such problems, you will get a time complexity of n square. It belongs to the order of growth of n square. You can observe that the best case will take n log n and the worst case will take n square. Are you all understanding? Hope you are getting this. I think we'll wind up the class here. This example I will deal in the next class. Is that clear, students? Is that clear?
Yes, ma'am.
Okay. One or two questions I'll simply pose for you all. Tell me which is the pivot element in our problem. Quickly. Pivot element in our example. Which is the pivot element? Quickly, students.
The first
The
element is
element.
valid,
First
ma'am.
element.
First element is itself your pivot element. Can I choose any element as my pivot?
Yes, ma'am.
Yes, so you can choose any. There are different variations of QuickSort. Remember, students, that this question definitely they will ask in your Viva. You should not tell, no, ma'am told me only first element is pivot. Any element can be chosen as a pivot element. Based on which the algorithm will vary. Partition algorithm will vary. Okay. Okay. When does the worst case occur in QuickSort? Situation when worst case is occurring, what happens? Okay. What is the input for which worst case occurs?
The array is already sorted, ma'am.
Sorted either in the ascending or in the descending. So in that case, what happens? I want what happens after the partitioning? What happens after the partitioning?
Ma'am, the problem is divided into two sub-problem. One sub-problem of size 0 and other of size n minus 1.
Minus 1. Very good. So what is the time complexity in the worst case?
N square.
Okay. Time complexity is n square. Okay. So what is the time complexity if it is in the best case? Girish? Girish?
N log n
N log
base 2.
n base 2. Why? When does this best case occur?
When
Ma'am,
the
when the
elements
pi
are not in any order.
Not in order, but what is the case when it occurs best case? Yes, Rakshita, over to you.
when the pivot element is at the mid position.
Yes, the pivot element occupies the mid position. Such a way the input is given. Okay. Similar, it becomes quite similar to which algorithm if it occupies the mid position.
Merge sort.
Sort. Right. So is there any what do you tell? Combining process in mud sort?
Yes, ma'am.
Combining process in mud sort.
In merge sort it is present.
Oh, sorry, quick sort. Sorry, combining process in quick sort.
No,
No,
ma'am.
ma'am.
No, because whatever is happening, it will be done within the input array itself. Okay. So as an assignment, I just want you people to solve this recurrence relation using backward substitution method. Okay. You can omit this C, not required. Okay, just solve this, and you all know T of 0 will be 0, nothing to do. T of 1 is also 0. So using those conditions, you can solve this, and you can also solve this using master theorem, because I keep on telling you, but I don't know whether how much you are understanding this using master theorem. Okay, so try doing the same in your books, assignment books. Okay, we'll see you in the next class. Any doubts? You can quit. You can attend the other class, ma. Next forthcoming class. Thank you, students.
Thank you, ma'am.
Thank you.